In this problem, we are looking at 331 students went on a field trip. 6 buses were filled and 7 students traveled in cars. How many students were on each bus? So let's write the question. How many students on each bus? Now that word each means division. That's important. My units though, what am I looking for? I'm looking for the number of students. So when we get an answer, it will be in terms of students. Let's highlight. 331 students went on the field trip. 6 buses were filled. 7 students traveled in cars. And then we want, of course, the word each, which we've already underlined. So let's write out our information. We have 331 students. We have 6 buses filled. And we have 7 students who traveled in cars. Now before you jump the gun and throw out the buses, what were the buses filled with? Students. So all of these pieces are important. Students, buses filled with students, and students in cars. We don't have any junk in this problem. So let's set this up logically. We have the buses plus the cars equal all the students. Nobody went on motorcycles or by airplane or anything. It's buses and cars. What is the unknown? What is it that we don't know? We don't know the number of students on a bus. So I'm going to use B. That's the unknown. I don't know how many students are on a bus, but I do know that there were 6 buses. Plus 7 students went in cars, and that is a total of 331 students. So there's the equation that we need to solve. 6 bus loads plus 7 in cars equal the total number of kids or college students. They don't have to be kids. So here's the variable. Here's the constant. And you know what to do from here, I think. U minus 7. Cancel. And copy. Be careful. 331 minus 7 is 324. So that tells me that on 6 buses there were 324 kids. I want to know how many kids were on one bus. So I'm going to divide by the 6. 324 divided by 6 is 54. So let's check our work. Let's actually plug it back in there and see. If I do 6 buses times 54 kids or students, let me stick with the word students because that's what it says. 54 students. So do 6 times 54, and you can use your calculator, that's fine. That's 324 plus 7 that went in cars. Does that match up? It sure does. The 331 that we started with. So we can say that that work is correct. So the answer to this question, remember, is this. There were 54 students. And we know we needed students. That was our units on each bus. Always make sure that that unit matches this one. That these two up here and down here match up. Okay, the next one is called a consecutive numbers problem. These are very, very common in algebra books. The sum of 3 consecutive numbers is 72. What is the smallest of these numbers? So we are looking for 3 numbers, but in particular we're looking for the smallest of the 3 numbers. So the unit that we want to focus on eventually is the smallest. Another word that you need to know is the meaning of consecutive. Consecutive means in a row. So you need to know what that word means to understand this problem. So let's highlight. We know that we have the word sum, 3 consecutive numbers. There's the word is, and then 72. I know that is my equal sign, and I know that add is sum. So it is saying to add 3 numbers in a row and you'll get 72. So what they're telling me is that the first number plus, because we're looking for a sum, the second number plus the third number equals 72. That's what this word problem is saying, that a first number plus a second number plus a third number is 72. So to set up a consecutive numbers problem, you want to focus on this one as the first. I'm going to call that F. The second number, if they're in a row, would be the first number plus 1. So you would have to add up the first number and then take it 1 further. And then the third number would be the first number plus 2 spaces. And this is the pattern that you will always use for sum of consecutive numbers. It will be F, F plus 1, F plus 2, and you could keep adding 4th, 5th, 6th numbers all you wanted to. You just add 1 each time. And so all of that is going to turn out to be 72. So what we have here is a total of 3 F's plus 1 plus 2, that's 3, is 72. And this is the problem that you and I need to solve. So I'm going to go ahead and put my power T right in there. Here's the variable side, and here's the constant side. So we are going to subtract this 3, and we have 3F equals 72 minus 3. So that's going to be 69. Divide by 3. And you're left with F equals, use your calculator, 23. So this is telling me that our first number is 23. So let's see if this proves to be true. The first number is 23. Now if they're in a line, what would the next number be? 24. And the third number would be 25. And if we add those, we get 9, 10, 11, 12, carry 1. There we go. So this definitely checks out. And we were told to find the smallest number of those three. So the smallest of the three is what? 23. And these seem very, very difficult. I know they do. But once you do a few of them, this is the same. The pattern is the same every time. So if you see 10 of them, they will all work exactly the same way. And I like that about them.